Let's see. Let's go for a sound check. Sound check. Okay, it works. That's good. No golf practicing for me. Just making sure that worked the way it was supposed to. Good. Okay. All right then. So I was coming up with a bunch of tests here, and I was trying to cleverly come up with tests that would fail in numerous ways that would tell me exactly what the problem was, and test several things at the same time. But I think I've done enough testing for precedent's sake now, and now I can do some testing for. So 5 minus, for 5 times 6 minus 6. Yes, that should be 1. 5 minus 1 times 5, 4 times 5. So that should be 1. Now we'll do this should be done in left to right. So it should be 1. That should also be 1. That should be 0. also be 0. That should be 0. Let's see here. I want to come up with something where the precedence, fact that it's L to R, and there's no precedence, actually matters. So there'll be a test that fails later if I ever fix that. How about this? There we go. So this will be 1 and 0. So this will be 0. This will be 1 if ampersand has higher precedence, and this will be 1 if it's evaluated L to R. No, it'll still be 0. It'll be 1 if ampersand has higher precedence, and it'll be 0 if it's evaluated L to R. And then we'll do a 1 or 1 case. Right there. So these are a bunch of different results. And I'm annoyed that I have to I can at least tab them all at once. But I'm annoyed that I have to line them up by hand. It should be smart enough to do that for me. I know that Emacs would be if I were doing it in Emacs. This one is tricky because I don't actually have a way to see the results of all of these expressions. I would like a way to see the results of all of these expressions. And so, yeah. Have to figure that out. Parser.hpp. If you look at parser.cpp, evaluate what does statements evaluation function do. So we have numeric literal, statement list. Yeah, this one will in fact output the result of every statement, but not in a form that we can actually capture properly. So in order to do this test properly, we need an evaluation context. I could split this up into a whole big bunch of different tests. I'm not going to do that right now. But I could split this up into a whole big bunch of different tests. we'll do this, and then we'll, yeah. Yep. That didn't have the result I expected, but I was kind of expecting this. That was input, and then the output was this. Oh, actually the output is exactly what I was expecting. I got the right thing here. But the evaluate, I didn't realize that I'd actually written an evaluate function for booleans that handled ampersand properly. So this is evaluation operation for binary. Okay, and indeed, there we go. I have put it so it should have. So this one failed because, well, should have gotten this answer. Is this answer the correct one? So let me cut and paste it here. I'm going to take the output from the test failure and make it be the like this. Yeah, that's the right way to do things. So let's look. So all these individual assignment statements. Yep. 5, 1, 6. Yes, yes, yes. 5 minus 1. Ampersand 1. So it got the grouping right. 5 times 6 minus 6 ampersand 1, and so there 5 times 6 minus 6 ampersand 1. Yep, got the grouping right there. 0 and 1, 1 and 0. 0 and 0. 0, 1, or. And it got the grouping right there. Left to right, left to right, left to right, left to right. Yes, all of that is correct. So, we'll just do this here. This is ugly. Terrible. Shouldn't do it. In Emacs, there's a really fast way to do this. Like that. Okay, so let's see what happens when we do this. What? Oh, it's because it needs a close parent first. There we go. What? What is this? That's... Right, that should... Did I need to recompile this before running it? Right? That's... What the heck is going on here? Because the expression that it gives here, result to infix strings... Oh. That's why. I changed the wrong one. Now I messed up this test. So we're going to have to see what this test... Yeah. Okay, this is better. What does it not like? Oh. Yeah. First, no. Is that better? It also needs a trailing backslash n. Yep. Now we bit past it and we get this one. So this is what it's spitting out at us as the result we should be getting. And then we should look to find out whether that's actually the result we should be getting. This, by the way, is a terrible way to write tests, I would like to reiterate. So 5 1s 1 1 ampersand top level minus 5 da 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 da, yes, ampersand da 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 da, yes, ampersand da 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 da. Yep. Yep. This all looks correct. So, I'm basically deleting a specific number of spaces to account for the indents. Okay, that's how this should work, and the last one should be that. Oh, no, 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 there was more. Whoops. There we go. Okay, that should be the rest of it. let's see here. Why all these initial set queues? Well, that's very interesting. I don't know why the two initial set queues are done up with a smaller number of spaces or larger number of spaces, and the remaining only have two. That's something I'm going to have to investigate why that happens. But for now, we're just going to just remove the extra spaces from the spots where they don't belong. Oh, I see. These are all supposed to have 4. The code wasn't wrong. My test case was wrong. My test output was wrong. There, that's better. Okay. So in this one, they all line up under the O. This one, they all line up under the O. So that's not the problem anymore. One other obvious problem. There. All right. So we've gotten tests that give us the results that we want. Now we need an evaluator that does something a little more sophisticated than the current evaluator does. Because in order to write the test that I need to write next, I want an evaluator that does something a little more sophisticated than the current evaluator does. All right. So first we're going to do this. And this is interactive commit. No. 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 Yes. No. Yes. 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 Basically, we're looking for changes where the only thing that's changed is this has been removed. Tokens : has been removed. And we want to record all of those changes separately because they're kind of noise. They're unimportant changes and unrelated to the major other changes. Yes, 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 no. Yes. This weird logic with the fall throughs, that was way too clever. Yes. 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 Okay. So let's see what the changes are that we actually committed. Okay. So we basically committed this. Again, removing tokens : removing tokens : basically, yeah, a bunch of noisy changes. We'll remove the something went wrong with my audio and I got blasted with static in one ear. I don't know what happened. That's why I startled so quickly. I don't know if my headphones are working anymore, actually, because that was a very unexpected occurrence. Are my... Yes, my headphones are still working for audio. Good. Okay. So, not see here. I'm still getting the weird bursts of static in one ear, and I don't know why. I think one thing that I'm going to do is mute output. Then maybe that will stop that from happening. If anybody's listening, do they hear random blasts of static? Or is it just in my headphones? Making sure that... Yep, with mute on, you guys can still hear me. Okay. So, yep, all the changes are tokens : related changes. And let's see what kind of a diff I have for the existing stuff. So we have, basically for the tokens bit, adding the ampersand. Oh, this is in parser. So in parser, adding ampersand is as a thing. And then in here, going to parse bool term instead of parse expression. Test. Then we are adding these as tokens. Yep. Okay. Now, if I really wanted to do this, because just a bit. On add Boolean, not bitwise operators. Okay. Now we should, the thing that I want to do, actually all of the evaluation stuff here in parser node, the stuff that happens in parser node, or parse node. These are all visitors, and the visitor should, yeah. There should be kind of a one Boolean or one virtual function. I don't know. But I'm tempted to add a evaluate context here. I'm not sure how to do this in a way that I would like to. I need to think about this for a while because, so evaluate here, what is the problem? This is a virtual function, and implementing these using virtual functions works. There's a kind of a weird flexibility issue here, which is suppose evaluate, like these are all different forms of evaluating, right? But I get different results out of them. I get strings or whatever out of them for evaluating them. And one thing, of course, that is true about this is it's not completely true. So evaluate and infix both traverse the tree of parse nodes in the exact same order. From left to right, the operator applies before the left, and then the right, and then the operator applies, and so on and so forth. Now, evaluate. And so these are kind of the same function. And then this is a different function because it actually goes through them in a different order. It evaluates the children, and then it does something with the children, and then with the results that it gets from the children, it does something with the parent, with the data in the current node, and then it returns that result back up to its parent, who's been doing things with both of its children, and then combining the results and doing something. So prefix visits both children first, then does something, then returns to the parent. Infix visits the left child first, does something, visits the right child, and then returns to the parent. Possibly, again, doing something. But the whole point of, these are different traversal orders. And evaluate traverses in the same order, right? Does something, goes to the left, evaluates the result, gets an answer, goes to the right, evaluates. It kind of does it in the prefix. Yeah. The difference between prefix and infix, is that true? It's not completely true. So why would infix versus prefix matter? So one way to think about it, right, is you go to the parent, you go A equals left, B equals right, return, A plus B, right, as your thing. And, that's the same for prefix as well, right? Return plus AB, right? And for evaluate, it's the same. It's return A plus B, right? Like that. So all of these are essentially the same function. It doesn't really matter whether it's infix, prefix, or postfix. Except we aren't even doing postfix at all here. Now, if I wanted to be really sophisticated with infix, I would be looking at the precedence of the things below me and adding in parentheses. If the precedence of the operator that I'm going to sending into for the child is higher than my precedence, then I'd put parentheses around, or I wouldn't bother to put parentheses around it. But if the precedence of the child was higher or lower than my precedence, I would put parentheses around it. Yes, that's how it would work. So if I were star and the node I was descending into was plus, I put parentheses around the plus because it's in fact supposed to happen before the star. It's supposed to be bound that way and not the other way. But that can also be done within, like that's an infix, and that can be done within the bounds of any of these traversals. Really, the only difference in traversal order would be so here's an example here where traversal order is it matters a little bit more. Like, suppose I change the definition for operator ampersand to be short circuit. Well, that would mean that when I evaluated, I needed to evaluate A and then check, is A 0? If A is 0, then I don't even need to evaluate B. If anything other than 0, then yes, I do need to still evaluate B. To make sure that it's also 1. And so if it were short-circuit evaluation, it would matter a lot whether I actually traversed one before the other. Anyway, this is a problem that I need to solve. I think maybe I want to stop using virtual functions to solve it. Maybe, I don't know. I need to think through the visitor pattern, because the thing to do this with is the visitor pattern. I need to look into the visitor pattern and maybe whether I actually want to be using virtual functions or not with the visitor pattern at all. Yeah, that's what I need to do. So, anyway, because I'm stuck at this impasse where I have to do some design thinking, and I don't think that this stream is conducive to me doing a bunch of design thinking, I am going to sign off for now. Although I will go and at least do one thing, which is there is, in fact, a standard visit with variant types, which I actually do use for the token list. And so I could make the parse node be just a variant type instead, the same way, and do something similar to it here. I don't know. Again, I'll have to think it through. Anyway, have a good day, all.